Okay, so here we have a U5000. This one has already been across the bench once. And it has been sent back to me because it has failed after I sent it to the owner. And it's the first time that this has occurred to me. And it makes me look bad and feel bad, but it's not really my fault, but I still feel bad because I always test these for at least almost close to somewhere near 4 hours after I do the repairs. Now, some people might look at that and say, well, that's not enough time. You need to do 12 hours, 24 hours. Well, I don't think so, because if something is bad and it's going to fail within 4 hours. It shouldn't take, 24 hours for something to fail. That's just kind of a little bit overkill if you ask me. But what happened is that this was working perfectly, no issues, ran fine for me for my 4 hours. Sent it to the owner. He hooked it up in his 720. And it worked fine for him for half an hour or so, then the blue went out. So we have a U5000 here with no blue. And I've already been in talks with the owner and gone back and forth and said, try this, check that. And he's gone through and done all the inspection and the testing and everything on the neck board. He's also replaced the blue transistor and still no blue. So we're going to see if we can't figure out what's going on. So I have two videos here back to back with no blue. As we've talked about before, it's red, green, blue, red, green, blue. So before we even mess with the neck board, because it's already been gone through, I haven't inspected anything. Well, I did inspect the main board. I'll show you some stuff with that. But as far as the neck board goes, I didn't cut off the back piece. I didn't really do anything because it's already been worked on. So what I'm going to do is actually remove all of the components here. And I went and got an entirely new or replacement neck board from another 5000. I have a couple on hand that I have repaired, and this is a fully working, no issues neck board for a U5000. So we're going to hook this up and see if we have our blue. If we don't have our blue, we know it's a chassis problem. If we do have our blue, we know it's a neck board problem. So if we hook this up and we have blue, I'll hook this back up and verify that we don't have blue. If we don't in fact have blue, then we know that it's a neck board issue. If we don't have blue with this one, then we know it's a main chassis board problem. So let's do that first. But before we do that, let's take a look here. A couple things I noticed is that the linearity coil has broken. Not broken, it's just the holder here. The glue has failed, and this is probably a result of shipping, but I can glue all this back together. It should be sitting like that. Now in theory, it shouldn't really be that big a deal if it's folded over, but there's a magnet on the top of the coil, which is loose now. There's a magnet on top of the coil and a magnet on the bottom of the coil. Now those magnets have to be in place or you'll have vertical linearity problems, crazy issues, where half the screen will be squished, other half will be tall, things like that. So we want to get that resecured. I'll get it resecured before we get it all shipped back up or shipped back and boxed back up. I'll take care of that. And then the horizontal width coil is all loose. All of the legs that hold it in place have broken off. And if we look in here, I don't recall this being like that when I shipped it back to him, so I don't know if this happened secondary or really what's going on with this. But if we look here, we can see that the legs here are kind of broken off from the posts, and it's only really being held in by the two legs that are part of the coil here. So I'll get that fixed as well, not a big deal. But in the meantime, let's get the tube set up here and let's plug in our known good working neck board and see if we get blue. And we're hoping that let's see, what are we hoping? We're hoping that we do get blue. That way we know it's not a problem with the main board. I can't recall really ever a situation or circumstance where a missing color was something with the main board, unless of course it was a solder joint here on the header pins, but I've already reflowed that. Part of the repair procedure that I did before, well, the first time around, was cap kit reflow and inspection and everything and rework. And as part of my reflow, I always do the header pins, and I always do the header pins for the power connector and everything and anything else that needs it. So I know for a fact it's not going to be a bad solder joint for the header pin. So let's go ahead and get this in here. All right, so we're all hooked back up for our neck board. So now let's get it on a tube and see if we get our blue. Okay, we're all set up, ready for testing. This is set up for medium resolution. So I have the test pattern generator here. Here is the original neck board that we assume is the cause of our missing blue. That is my replacement from a known good working setup. So let's turn this on and see if we are missing blue. 1, 2, 3. Oh, you know what? Every time I don't count, every single time I don't say anode neck, yoke ground, power, video, remote, every time I don't physically say that out loud, I forget something. That's why it's very important to actually do that. So now we'll try again. 1, 2, 3. All right, we are on and working. And what is going on here? I don't have any video. Why don't I have any video? Test pattern generator's on. We're on the right selection for our medium. We're on medium. I'm set to medium. We got a good sync. What is the issue? Brightness, contrast. Hey, there we go. I was turning the wrong pot. It's been a long day. Brightness, contrast. Let's just scroll through here and see if we have blue. And we absolutely have blue. So we have a neck board problem. And without changing anything settings, let's go ahead and just turn this off. And I don't think I can get this swapped out with one hand. So let me swap this out. We'll come right back and see what we get with the original neck board here. Just like that, original neck board is installed. The one we just tested is removed. Let's see what happens with this one. 1, 2, 3. All right. We didn't discharge the tube, so we didn't hear it energize, but it's on and running. And we have no red or blue. Oh, yeah, we do. Red and green, no blue. Red just took a while because the tube is tired. Let's bring our contrast down. Holy cow. Yep, there you go. No blue. So problem confirmed and verified neck board issue. So let's take this back apart, see what we can find. So here we are with the neck board. I have removed it again once from the chassis. And let's go ahead and cut these zip ties off and expose what we have going on here. Okay. Let us examine here. These are a bit worse for wear than I think when I had it last time. Yeah, I don't think I would have left. I almost guarantee I wouldn't have sent it out like this. Because look at that. That's no good. I mean, the traces aren't broken. That's probably, that's why our green still works, and these traces aren't broken. That's why our red still works. Our blue, those traces are intact. This one here is a bit skeptical. Now the previous, well, I guess the owner of this, the previous person, I guess, he already replaced this. I told him to check this transistor and verify the pot's not open, and verify these transistors here, and verify these resistors, and verify these diodes, and all that checked good. What he said, everything checked good, so I can assume that it is, but we'll check it again anyway. It shouldn't be a bad pot here. Yeah, if all else fails, this transistor is bent over a bit. If we check everything and everything checks good the way that the owner of this said that it did, and we verify his results that everything checks okay, then I suppose we'll have to change out the 1203 chip. Now, like I say, this worked fine for me for a number of hours, and it worked fine for the owner for about 30 minutes, and then it lost blue. And we just verified that it was bad. So let's start with fixing. Let me turn my fan on here. Let's start by fixing these solder joints. Let's dab a little super glue under here. and use my tweezers, and let's just heat this up and push this down. There we go. Same thing for the rest of these. Put a little dab of super glue into there, and then get yourself some small tweezers, heat the joint up, and then push it down and hold it, and it'll stick right down flat to the board again. There we go. And it's just that easy. I need to get some water from my sponge over there. But, So now let's reflow these a bit. From what I can see here, it looks like the owner of this replaced all 3 transistors. Now that I look at this and see how long the legs are, they're much longer than they usually are. I think he replaced all 3 of them. That's what this looks like. I don't recall any conversations about all 3 being replaced, but that's not a big deal at all. Okay, I mean, I think that's a lot better. Clip that. 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 Okay, that's not bad. Who's messaging me? What am I getting here? Okay, let's see. Let's get rid of these. And let's grab our alcohol. Oh, have another one, you freaking lush! Okay, that's much nicer. That looks a lot better. Well, it did until the alcohol dried up. Let's clean that up again. May not be able to make it look better than what it is. Well, we'll have to live with it that way, I guess. Okay, now that we got that situated, we can go ahead and start wringing out some of this stuff. Let me hit a couple of these here. Yeah, the rest of this seems okay. Alright, let me reposition these a bit. Yeah, it's too late now, but I forgot to flatten these out, but it's okay. As long as they're, see, now they're secure. And yeah, so we'll live with that. That's fine. Well, it's not too late, but it's okay. So let's go ahead and start wringing some of this stuff out here. I say wring out because I'm former military and civilian aircraft stuff. So let's start with this. So we should wring 0.6 voltage drop to one leg and nothing to the other. So there's our 0.6 and the other leg is nothing. 0.6 and nothing. 0.6 and nothing. So I'm fairly confident we don't have an issue with the transistors because it's already been replaced. So the next step is to go through here and test all these other various components. So let's zoom out a bit and let's test our main resistor here. 2.6K, 2.7, close enough. There's a little diode underneath it. We'll test the little diode. Diode's good. We'll test our U5000, this control transistor for this transistor. And if I recall correctly, it should be 0.6 to each side. 0.6 and 0.6. Other ones read the same. 0.6 and come on. 0.6. Uh-oh. That's not good. This is our red transistor. But this transistor is not reading properly. That's weird. See, if we go back and check these, this is a good reading. Negative lead on center, and then each leg should be 0.6. Come on. What's going on here? Am I not doing this right? What was I just doing? Why is this different now? 0.8? Hang on a second. Something's not jiving here with this. I'm going to reflow these. Let's see what that does. Let's just go to this next point here. There we go. See, okay, so red lead on the middle. I don't know what was going on there. Red lead on the middle, which is this trace, and then each leg, 0.6, 0.6. Red lead on the middle, 0.6, 0.6. Red lead on the middle, 0.6, 0.6. I don't know what happened there. that was weird. Okay, so these should be good. These should be good. We shouldn't have an issue with these transistors. These transistors, our main resistor checked good. This diode checked good. Let's check the L701. The little inductor. There's an inductor right in here. It looks like a resistor, but it's actually an inductor. We're going to test that for continuity. And that's good. 1 ohm. Okay. Moving right along. Again, if we don't end up finding anything, it very well could be a bad 1203 chip. We'll test this diode here. That's good compared to these, and that's good. Test these resistors. 40 ohms and 400. 40 ohms. 400, so it's not the resistors. This resistor here is 55 ohms, same one over here. Close enough. Let's test this resistor here. 100 ohms, the one next to it. 100 ohms, so it's not that. Okay, well, next down the line is going to be one of these three. Could one of these three resistors, or one of these three transistors. Could be one of these three capacitors. Yeah, those are all okay. So let's test these resistors here. We'll start with this one here. And we got 100 ohms, the one next to it. 100 ohms, this one here. Ohms, so it's not the resistor. So let's test these 3 transistors here. Should be the same type of thing. We go red lead in the middle. Each leg should be 0.6 voltage drop. Or, well, I could be wrong. Let's try it the other way. There we go. It's black lead in the middle. So there's 2 different types of these little transistors. They're NPN and PNP. And I'm too lazy to look up which ones are which. So it's either negative in the middle. Well, it depends on where the base collector emitter are. Does it say on here? It doesn't. I always just test these. You're just testing to make sure they're not shorted. Is really all you're doing. So I just always go to the middle with either the red or the black. In this case, on these over here it was red in the middle, but over here it's the black in the middle. So if we put black in the middle and touch each outer leg, 0.6, 0.6, 0.6, and 0.6, 0.6, and 0.6. Well, it's looking more and more like we have a bad 1203. We can just do a quick inspection to make sure we don't have anything else going on that's broken or out of whack. Because I don't think anything is broken, because it would not have had blue and then lost blue if something was broken. It could have been a resistor that heated up, but we didn't see any bad resistors. I don't see any broken components. So I think what I'm going to do, let's test our, these are all set to the same, so they should read the same. Let's test our pots here. 453 and 500. 500 and 500. Alright, so the pot's not open. And we've tested the pot, the resistor, the capacitor, the diode, these 2 resistors, this transistor, this resistor, this diode in here, the I just lost the word. There's another resistor in here I guess we could try. There's another resistor down inside here. It's right here. The coil, L501, the coil that's in there. Let's test this resistor and see what it reads that's down in here. 151, I think that's good. Yeah, so that resistor checks good. Our traces checked good. So, yeah, I think we're about at the point where we suspect the 1203. Now, I've actually got a couple, I think. Do I have one in here? I don't have one in here, but I do have a neck board. But I'll be damned if I can remember what I did with it. I'll have to try and find it, but what we can do in the meantime is do some comparative readings to ground here and just see if we have anything that reads weird here. Let's just go to ohms. Well, let's start with this. Let's go to ground. That's ground. Well, nothing odd there. So nothing reached to ground on here that shouldn't. Well, I gotta say, this one is stumping me a bit. I mean, we could change out the transistor again, but I don't think that's the problem. So let me do some more poking around, and we may end up just changing out this chip. So let me do some more stuff here, and I'll see if it comes down to this. So I have to go find my other neck board that I have with this chip. So at the very least, I'll have to cut away here and find this chip in case we do end up needing to swap it. I'll have to have it on hand here. So I'll be right back. I couldn't find anything else wrong, so I found that spare neck board I've got that had this chip in there. And I wanted to kind of stop here and show something, is that I removed the original 1203 chip, and if we look at the board, it's burned here. Right here in this area, it's got a bunch of hot areas, and right there it's kind of burned up. If we look at the bottom of the chip, you can kind of see the same area where it's got a bit hot there. And so now I'm even more skeptical of this chip being the cause of our issue. And it does happen, you know, it's another component that fails. Just unfortunate it picked that one time to fail. It failed on the owner and not on me, so yeah, so I'm gonna go ahead and pull this one out and get it in here, and then we'll test it and see what we get. So hold on one moment. Okay, so we're all hooked back up. Our new our replacement 1203 chip's installed. The original one is sitting right there. The board I robbed it from is right here. So hopefully this works. If it doesn't, I'm about out of ideas. We know for a fact it's a neck board problem, and I've already verified that the transistor is getting hot, so it's not an actual bad transistor like we had in the previous video. So if we're unsuccessful here, it's going to take a bit more troubleshooting. So if this doesn't work, it's going to end up being something that I've never seen be the cause of this before, I'm betting. So it'll be a new one for me, and I guess a new one for you guys. So let's go ahead and turn on the generator, and fingers crossed. Let's see. 1, 2, 3. Alright, comes on. I gotta turn my light back off here real quick. Alright. And we'll know immediately once we get the checkerboard pattern. Well, it doesn't. Nope, that's awful yellow. Oh, crap. I went too far. Nope. Oh, son of a bitch. Alright, well. If it's not the transistor or that transistor or the resistor or the diode or the L501 or the resistor inside of there or the pod or any of these resistors or that diode or the transistors over there or the resistors around that or the 1203 chip, I don't know. This is going to be a fun one to try and figure this out now. Is it a bad neck? It could be a bad socket. But the socket wouldn't go bad. It's not an electric part. It's a mechanical part. If I wiggle this around, do I get anything? No, nope. Nothing. I don't think it's a socket problem. Oh, that sucks. Well, I'll have to go through component by component until I find the problem. So let me do that. And when and if I find the problem, I will report back. One moment. So something very wacky is going on here, and I'll be damned if I can know what it is, or if I can figure it out. So out of desperation, I shotgunned in a new transistor. New blue transistor made no difference. I shotgunned in another the little transistor above it that controls it. No difference. I shotgunned in the little transistor here that's part of the circuit. Made no difference. So I changed that transistor out, this transistor out, this transistor out. I rang every component, every resistor, every diode. Nothing was out of spec compared to the one that's working. And I decided to go ahead and throw it on here and do some more testing, tweaking pots. Did nothing happen, and as you can see, still no blue. But watch what happens when I crank the contrast. If I crank the contrast, you see how the red and green bleed, but watch this. Blue! The contrast is cranked completely up. If I turn the contrast down, the blue goes away. All I'm doing is tweaking the contrast back and forth. Blue, no blue. Blue, no blue. Blue, no blue. Back down till we quit bleeding here. And nothing. something is very wacky. Now, if I was to just simply, exactly as this is, take that neck board off, put this neck board on, I have blue. Blue works fine, easy for me to say. Put that neck board back on, no blue, unless I crank the contrast. So I have no clue what's going on here. Look at this. I'm just turning the contrast up and down, and I'm blue, and I don't, this is very odd. So yeah, if I turn, where'd my little screwdriver go? Did I lose it? Here it is. Okay. If I turn the blue pot all the way up, all the way down, all the way up, nothing. So I'll put it back where it was. Yeah, there's no sub-contrast pot on here like there is on the 7475. So I think what I want to do is I want to actually check and see what R811 reads. Now R811 should affect all three colors individually, but I want to check and see just what it reads, and if it's, you know, 75K or within 50 to 100. That's not the issue. There's something on this neck board, I think, that is, you know, out of whack. I think I'm just going to go off the blue pin. The blue input pin is right here. You can see BLU, and it goes up to some components here, and then it goes straight over to this resistor and this transistor. So I've already I took the one out of here, took the one out of here, and I put a brand new transistor in for the blue. So all that's been replaced already. The only thing we have left to do is to follow the trace, and I may just end up changing every single component one at a time on the entire blue circuit until I find it. But let's test R811 first. I've already gone through and tested all that stuff on here, and everything tested okay compared to the working one. So you know, we learned from the last video that just because something tests good doesn't necessarily mean that it's actually good. It could still be bad. But let's test R811 here. Let me go ahead and set up, and I'll read it, and I'll see what it reads. If it reads good, then we'll move on to replacing the components. I don't know. This is just very odd. I've never seen anything like this. Why does it only affect blue? Why does the contrast affect only the blue? And it's not a main chassis problem, because with this neck board, like I said, blue comes on just fine. But I still want to check R811 because maybe this one's less sensitive, I don't know. But more than likely R811 is going to be just fine. So let me get that done, and I'll do some more testing and see what I found. But I did want to point out what's going on here with this. It's just very odd. So stay tuned here for a moment, and I'll see what else I can find. Okay, it's like 6 hours since the last time I left you. And I've been shooting this and shooting this and shooting this, and it has been kicking my ass up and down Main Street and back twice. Just up and down Main Street and back, dragging my body up and down the street. But I ended up breaking free, and I found the problem. And I mean, I've got a whole mess of crap over here, neck boards and parts and pieces and all of my stuff, and what I ended up doing was one at a time. I realized, well, let's go back here. So I know the blue circuit was working because when I would turn the contrast up, we got blue. But if I turned the contrast down at all from maxed out, the blue would go right away. We saw that. So I knew that the actual the color circuit was working because we had blue. And it was in the contrast circuit that was actually, I started tracing the contrast circuit. And I could not find anything wrong. I checked every resistor, every diode, every transistor, every capacitor. I couldn't find anything wrong anywhere on this neck board to save my life whatsoever. So it came down to the components that I couldn't test with a multimeter. I didn't have an ESR meter, I just had the multimeter. So the only components that I could not check with a multimeter were the little tiny polycaps. These little polycaps right there that are all over the board, right there, and they're all, you can see over here on this side, all those little blue polycaps with the black mark on them. There's the, I stole all those polycaps from a conglomeration of these two boards here, and I replaced every single stinking polycap, and you can see the blue one there, with everything with the black mark I replaced. And it wasn't until I got to the very last stinking polycap that it fixed the problem. That polycap right there which just happens to be on the blue, off the blue bias pot there. When I turned up the contrast and got blue, I could turn the pot and it would make no difference on the amount of blue. And in hindsight, I probably should have started there, but in all of my years in fixing these chassis that have missing colors, never in my wildest imagination would I have imagined that these polycaps would have been the cause of no color. And in this case, it was. I changed every single stinking polycap, and the very last one that I got to, I started from the bottom right off the contrast circuit and worked my way over, changing every single one of them. And when I got to this one right there, we've got blue. And if we turn up the contrast here, you can see that we have blue bleeds just like the other ones. So right about there. And yep, we got all of our colors. They look fantastic. And all this troubleshooting came down to one of these polycaps. Now I don't know which one it is. I would just take them off one at a time and toss them in the pile here. So one of those polycaps was bad, the original one that was on here, but I don't know which one it is in the pile. So all that effort, all that troubleshooting, all of that work turned out to be a bad polycap. So, lesson learned. If you get to this point where it's not the resistor or the, I mean, I changed the resistor, the little diode in here, I swapped the transistors a second time, changed this out twice, swapped it again. I swapped around all of the color pots. I replaced and swapped around the transistors right there, those 3 transistors. I replaced, I think, this very top 50 volt 10 microfarad. I replaced the 50 volt 4.7 over there. I replaced the 1203 chip. I replaced that resistor there and a couple of other parts, a couple other resistors. I did everything humanly possible, and I could not get that blue to come back. And it wasn't until I changed all the polycaps and replaced that polycap. Yeah, I've never seen that happen before in all these years, have missing color be caused by one of these polycaps. But that was it. That fixed it. And it's going on, let's see, I started about 6 p.m. when I got home from the arcade. I had to go up to the arcade and get some stuff. And it's now, let's see, 12:07 a.m. So 6 hours, around 6 hours I've been working on this no missing color problem. So that was it. I can't believe it. So thanks for sticking along here. Learning experience, definitely, for sure. And at least we have this knowledge now documented for further evidence and for future use. So I will, of course, hook up an actual PCB, let this run for 4 or 5 hours just to make sure that nothing goes bad. And I'm blown away. I've never seen that happen before. But that was absolutely the problem. Absolutely the problem. So, yep, thanks again for watching. Very, very good, very good example here of how things can go haywire when it's not something that's normally the cause. So we'll see you next time. Stay tuned for more, and I appreciate you watching.